In this video we're going to have an introduction to factorization, which will cover the basics of factorizing. So factorizing can essentially be thought of as the opposite of expanding brackets. So once you have factorized an expression, one or more sets of brackets should be present in the new expression. Unfortunately, unlike expanding where we can use the grid, there's no one technique for factorizing, so instead we need to look at several different techniques, and these are the ones we're going to look at in this video. So we're going to start off by factorizing by removing a highest common factor, or taking out a common factor first, and we use HCF or CFF as abbreviations of that. We're then going to look at factorizing using the DOPS pattern, which is the difference of perfect squares. And hopefully you've come across this one before, which says that if you have A plus B multiplied by A take B, then that expands to give A squared take B squared. And when we're factorizing, we simply go right to left. So we acknowledge that there's an A squared take B squared situation, and we know we can work backwards towards A plus B times A take B. And the last technique we're going to see in this video is when we factorize by grouping different terms together. So for the following examples, we want to factorize each of the expressions. So for part A, we have 6x squared plus 21x, and we can see that there are common factors between those two terms. So 3 goes into 6 and into 21, and we can see there's a factor of x in 6x squared and a factor of x in 21x. So that's a really long-winded way of saying that 3x is a highest common factor of those two terms. And then we need to think about what would we multiply 3x by to get 6x squared. And that would be the term 2x. And then what would we multiply 3x by to get to 21x? And that would be 7. So that is the factorized form for part A. Now we're not going to do this for every example, but we can actually check if we've correctly factorize this, and we check by expanding. So to expand this, we can set up a grid, and this term out the front, the 3x, can go here, and then the term inside the brackets, 2x plus 7, can be written as 2x plus 7, and now multiplying 2x by 3x does give 6x squared, and multiplying 7 by 3x does give plus 21x. So we can see that this expansion here matches our original expression, so that means we've factorized this correctly. So I'd encourage you to pause the video at this point and have a go at B before I do it for you. But if we do have a look at B, we can see that we have negative 2x squared plus 8x has a highest common factor of negative 2x. So we can remove negative 2x as the highest common factor, and then we do the same thing as we did in part A, and we think about what would we multiply negative 2x by to get to negative 2x squared, and that would simply be x, and then we'd need to multiply negative 2x by negative 4 to get to positive 8x. So we won't check this one, but I'm pretty confident that that is the factorized form for part B. And down the bottom is just that sentence to watch out, because it's very easy to make a mistake when negative signs are present when we're factorizing. So for part C, we want to factorize x squared subtract 16. And first of all, we could check for a highest common factor, or removing a common factor first, and you can see that there's no highest common factor between those two terms. So the hint here is that when there are two terms and no highest common factor, it might be a difference of perfect squares. So if we attempt to factorize it using a difference of perfect squares, we would have x and x in this position, and when they are multiplied together, that eventually gives x squared. And then the DOPS pattern would have x plus something and x minus something, and we want that term to eventually multiply to give negative 16. So we're going to have x plus 4 and x subtract 4. So that is the answer to part C. When we look at part D, we can once again see there's no highest common factor between 4x squared and negative 49. However, it does resemble that a squared take b squared form, which is related to DOPS. So when we attempt to factorize it like that, we know that 2x, when it's multiplied by 2x, will give 4x squared. And then DOPS says that we would have 2x, and we could do the subtraction in the first bracket and the addition in the second bracket. It doesn't matter what order you do that in because it's multiplication. And then we need this to multiply out to give 49. So we could have 2x minus 7 and 2x plus 7. And that would be the factorized form for part D. For part E, we want to factorize x plus 2 all squared minus 3. And again, there's no highest common factor, so that means that we can try and use adopts because there is a positive term and a negative term. However, this time, that 3 is not a square number like 49 was last time. So the hint here is that we often need to use surds to help factorize when we're using dots. So even though there's not a nice value that is the square root of 3 being an integer, the square root of 3 can be written as just that, the square root of 3. So we're going to attempt to factorize this. So this is going to equal, and we'll have 2 factors by the end of it, because it's adopts. The first term will be this x plus 2, so we'll have x plus 2 and x plus 2, and when we multiply that out, that would give the x plus 2 all squared that appears in our original expression. And then as we think this is adopts, it'll be x plus 2 plus something, and x plus 2 take something, and then that something needs to give us 3. And we use the square root of 3 to do that. So we'll use the square root of 3 there. So that is the factorized form for part E. Now part F, again, has no highest common factor between these two terms. And the other thing that's different about this one is that the negative term is the first term. So if you prefer, you could always write this as 50 subtract 9x squared. And now when we attempt to factorize this, once again we'll have 2 sets of brackets appearing. And this minus 9x squared, we know 3x multiplies by itself to give 9x squared. So this could be 3x and 3x in this position. And knowing that it's adopts, we're going to have that plus or minus pattern appearing within the brackets. And now we need to have a think about what multiplies by itself to give 50. Well, that's simply the square root of 50. So we would have square root of 50 plus 3x, and the square root of 50 take 3x. However, the square root of 50 can be simplified. So that can be written as the square root of a square number, 25, times the square root of 2. And the square root of 25 is simply 5, so we can write it as 5 root 2. So in its simplest form, this factorized expression would be 5 root 2 plus 3x, and 5 root 2 take 3x. And that would be the fully factorized and simplified version for part F. And now I'm not going to check by expanding that, but that's something that you could do to see if we did in fact get the correct answer. For part G we have 4 terms, minus 2x squared plus 6x minus 5x plus 15. And what we're going to do is factorize this by grouping, because there's not just 2 terms with a negative symbol between them, meaning it could be adopts, and there's no highest common factor. So the groups that you test are really a bit of trial and error, and sometimes you'll need to test different groups in order to fully factorize the expression. So the first way I'm going to try and group it is just by using the first 2 terms and then grouping the second 2 terms. So grouping 2 and 2 is a popular method that we're going to use a lot. So in the blue, the highest common factor between negative 2x squared and plus 6x is negative 2x, leaving behind x and minus 3. And again, just be careful with your negatives when factorizing. Then in the green, we can see minus 5 is a highest common factor, leaving behind x minus 3 again. So now the blue and the green have become 2 distinct terms. And the highest common factor between both of those terms is this x take 3 factor, which I've highlighted in purple. So to continue to factorize, this is going to be equal to, and we remove x take 3 as a highest common factor, and that leaves behind, in the blue we can see we have minus 2x multiplying x take 3, so there'll be a minus 2x left behind. And in the green we can see it was negative 5 multiplying the term x take 3, so this is going to be minus 5 in that position. So that is the factorized form for part G. And now for part H we're going to attempt to factorize it by grouping again. So first up I'm going to try grouping just the first 2 terms together and the second 2 terms together. So if we do that, this is going to equal, and in blue the highest common factor is 2, leaving 2 bracket x squared take 2b, and then in green the highest common factor could be minus 2x, leaving behind 2, and then we'd have minus b. However, we can't spot another common factor between those two terms now in blue and green, so this hasn't been a particularly useful way of grouping them. So instead we rewrite the expression, and instead I'm going to try a different set of groupings. So I'm going to have 2x squared, and I'm going to put minus 4x next to it, and then I'm going to have plus 2bx minus 4b. And now that it's lined up like this, I'm going to group these two terms together and these two terms together. So if we do that, we will get in the blue a highest common factor of 2x, leaving behind x subtract 2. And in the green, we can see we can take a highest common factor of positive 2b out, leaving x take 2 behind. As with the previous example, we can see that there's now a highest common factor, in this case x take 2, which means we can factor that out. So we're going to have x take 2, and that will leave behind from the blue side 2x, as that's what's multiplying x take 2. And in the green, we can see that 2b was multiplying x take 2, so there's a plus 2b there. So that is the answer for the factorization of part H. So after this video, you should be able to understand that factorizing is essentially the opposite of expanding brackets. You should be able to factorize an expression by removing a highest common factor. You should be able to factorize an expression using the difference of perfect squares pattern. And you should be able to factorize an expression by grouping terms together, but you may need to trial and error different combinations to be successful when you're doing that.